Hi, everyone. Thank you so much for joining our presentation today. It's really awesome to see the full room over here, especially considering there are so many good sessions happening at the same time. I hope that you have a wonderful morning with an awesome session in the morning. We hope that we'll deliver a good session for you today as well. So our session for today is going to be from zero to Microprofile Hero. And that actually was an idea from the conference organizers that actually put us together to actually come up with this presentation for you guys. So my name is Roberto Cortez. I was actually working with these guys a few months ago. In the meantime, I changed to another company called TalkDesk. Anyway, in the last couple of 10 years, I've been working a lot with enterprise technologies, mostly on financial and government sectors. And of course, building microservices in the last few years and been playing a lot with these kind of technologies. So now at TalkDesk, we are a cloud provider that provides cloud infrastructure to run contact centers. So of course, we're developing a lot of our stuff using microservices and now even Microprofile that we're going to show here today. So with us, we have our other colleagues, John and John Lee. So.
Yep. Hi there, I'm Jonathan Gallimore. I'm one of the software engineers at Tommy Tribe. If you haven't come across us, we've spun out of the Apache Tommy community. So I get to actually work on Apache Tommy for my job and actually get to implement some of the microprofile specifications that you'll see here today.
And my name is Jean-Louis Montero, so I live in France, and I'm also working for Tommy Tribe. So as John said, we do mainly middleware stuff. And we've been working for more than a year as well on an API gateway. I'll be taking the last part of the presentation, so I'll leave my colleagues to start now.
Okay, wonderful. Now that we got that out of the way, so one of the things that we like to do in our sessions is we like to keep these the most interactive as possible. So please feel free to interrupt us anytime you want to post any questions, so don't save your questions to the end. The only problematic part is I don't see very far away, so you might want to throw me something to call my attention. But these guys, they see way better than me, so it should be fine, right? Okay, so what's going to be our agenda for today? Of course, we're going to talk about microservices, and we're going to talk a little bit about what Microprofile is, which is basically most of the core of the presentation. We're going to have a look on all the specs overview that compose a microprofile. We're going to do a bunch of demos to you, so we have at least one demo per spec, but most of the specs we even have 2 or 3. So we're going to try to fit as much demos as possible so you can see things working, and then you try to figure out how you can use that on your own project. And then we're going to talk about a little bit about the microprofile future to see what's next. Not only on these specs, but also what's coming next that you might want to use when they come out. So, okay, who's here is doing microservices? Okay, a bunch of people. That makes sense because if you're not doing that, you will probably not be here, right? And who's not doing microservices at all? And who would like to do microservices? Okay, and who enjoys microservices? Interesting. I see a pattern over here. There's a lot of people. There's actually maybe like 75% of the room using microservices, but maybe like 20% they actually enjoy them. Yeah. And that maybe there's a reason for it, right? So we hope some of the things that we show you might make things a little bit easier for you guys. Okay. So, what people usually mean about microservices? These are some of the things that I heard when I was talking to people. They say that they're like small autonomous services working together, and they say like small enough but not small enough. By the way, how big a microservice should be? Does everyone have an idea? I don't know, maybe like 1,000 lines of code, 5,000, 5K, 10K, 1 meg? One functionality, okay. Maybe. I mean, the interesting here is no one can actually agree on that, right? That's another pain point. some people said it can be written in 2 weeks, and we promise we're going to talk about the 2 pizzas story, right? Everyone heard about that before. Single responsibility principle, something very similar to what you were saying. Feature, domain-driven design. So that's another option. And those are some of the things that people look for when they're doing these kind of architectures. But that for me, that was not enough. So usually, when I want to know about something, I go to Twitter and start asking questions to people, right? So those are some of the answers that I got when I asked them about microservices. So if you cannot build monolith correctly, why do you think putting network in the middle will help? I enjoy this one. Right? Say microservice one more time. You know, the only way to get into conference these days is to actually talk about microservices. That's why I start talking about them. But I usually don't like them. So one day microservices will share some lists and we'll call servlets. Right? Okay, so this is the how big should it be? You actually, especially when people ask me or answer me, it's going to be like 5K lines of code or 100K lines of code. You actually realize that you can actually put everything in a single line, right? Even a monolith. Will it make it a microservice? We don't know. You're not GameFam. You may not need that. And most people don't know what GameFam is, but they usually stand for Google, Amazon, Facebook, Apple, and Microsoft, right? I don't know if I should probably put these on the slides, but I don't know if you've seen, like just recently, Uber, they made a graph for all the microservices, and it was just crazy. They had like, I don't know, like 800 or something. It was huge and big. I mean, I was looking at that, and I mean, when did we lose control of what we were doing, right? Okay, architecture being developer nightmare, right? I'm pretty sure all your architects come to you, hey, I heard this new microservices architecture, let's do it. And then you end up not knowing what to do. Okay, so I was mocking a little bit microservice because it's easy to make fun of them. But of course, there are some particular reasons why you should use them, or why, if there is a reason for it, maybe those are some of the reasons you should follow them. So one of them, of course, is deliver features quicker, right? When you're developing a particular feature, and if you're just doing it into a service, of course, you can just deploy that pretty quick, and then people can just use it instead of waiting for the entire thing to be built on. Again, you have smaller and agile teams, right? So instead of having these huge teams working on the same monolith, you have people that are working on specific features, right? And they only have to agree on how they're going to communicate, which sometimes is harder than building a monolith, right? For me, actually, the biggest advantage of this kind of architecture is when you want to scale your application, right? So when you have everything in one monolith and you want to scale stuff, you have to scale everything. But usually that doesn't mean that all the services that you're having available on that particular piece of software, they have the same resource requirements, right? So if you think about Netflix, and those are the guys that popularize these kind of architectures, the service that they have to register a user has different needs from the service that they have to stream movies, right? So they have to be scale them independently, and that's one of the big advantages, one of the big motivations to actually develop these kind of architectures, and of course do the cloud deployment. Okay, then we come up with some of the challenges that we usually get. So talking about scalability, right? And cost reduction, resilience, especially when you have multiple services that are talking together. When you have a monolith and everything goes down, and it's fine, right? Or maybe it's not fine, but at least everything is down. Now, when you're having this microservice architecture, you have all these services working together, and then if one is down, you have to find techniques that you're not going to mess the entire system, right? Because if you have this architecture and one service is down and then the other ones are up, but still you're not able to grab anything from the system, it might mean that in practice everything is down anyway, right? When you have all of these services as well working together, you have to monitor to see what's happening. So that's another challenge that you have. And of course security, so you have to secure them all, and you have to propagate the security context across all the calls, right? Because you cannot have a person have the role to call a service and then the other service that receives the call should also know who's calling it to see if you're able to access whatever information that service wants, right? Sorry? Yes? One more challenge.
Yes, it's like having a separate database.
Having a separate database.
Big challenge.
It is.
I'm not sure why
I mean, those are like, I will still, I agree with what you're saying. I just think that mostly that's an implementation detail. So you're actually able to develop microservice with a single database, right? It's possible. Probably not recommended, but still, we might want to add that later. Thank you, sir. Okay, so now we come to the portion about what is Microprofile. So we've seen a little bit about microservices, seen a little bit some of the challenges, and especially, and actually let me ask you a couple of things before. So who's here is a Java developer? I'm guessing most of you, right? And who's here is the EE developer? Okay, a few, and Spring. Okay, most of you, right? And you should probably see, other than Spring, I mean, Spring actually have made a terrific work to actually help people develop microservices. But if you're looking into stuff like EE, Java EE, now called Jakarta EE, they didn't have a proper way to actually support all of the challenges of microservices. So Microprofile is something that came up to fill in that gap and help Java developers develop microservices in the environment that they love and they enjoy all the time. So Microprofile is an Eclipse project. It's completely open source. So who actually heard about Microprofile before? Okay, a few, wonderful. Yeah, I mean, let me see if I can remember. I think maybe 2 or 3 years ago. So I'm actually very happy about this because I was probably one of the first persons started to talk in conference about Microprofile. And it was somehow embarrassing because I usually have like 2 people in the room. Now I've seen people increasing in the sessions all the time about Microprofile, so that have 10, 20, 30, you know, having full rooms with people interested in Microprofile, so that makes me a little bit happy. And so Microprofile itself, it started as a version 1.0 with a subset of some of the EE specs, so CDI, JAX-RS, and JSON-P. And that was because when the vendors that were working on a Microprofile, they thought that those are the basic foundations to actually develop a microservice, right? And that's probably what you usually use when you do a REST endpoint. And now currently we're actually, so since 2016, so it's like 3 years, we're already on version 2.2, and look how much it was accomplished during those 3 years. So we got specs to do configuration, we got to do fault tolerance, chat propagation, health check, metrics, OpenAPI, OpenTracing, and REST client. There's also reactive streams standalone API that you can use. It's not part of the version of the main package, but you can still use it standalone. So, if you compare this and what was being done on EE, that's a tremendous amount of work, right? So all of these specs coming up in just less than 3 years. Now, so even all the specs that came, they also evolve over these 3 years. So fault tolerance is already on version 2.0, for instance. And one of the things that I haven't told you before is about JSON-B. So JSON-B also became part of Microprofile. So all the 8 specs that you have over here are completely new specs. These 3, CDI, JSON-P, and JAX-RS, they were chosen because at the time we only have E7, and JSON-B only came on E8. But when JSON-B came up on E8, it was also pulled down and moved to the Microprofile package, right? So why Microprofile? The problem was the slow innovation on Java EE. So if you look, it's not about criticizing anyone, but Java EE is being about standards. Is being you have to wait for things to be stable, and then sometimes the work was being a little bit slow. And on all these microservice architecture, and all these microservices tools and frameworks, they require a lot of innovation and to be fast, because if you look on when microservices came up and when the concepts started to come up, maybe like 4 or 5 years ago, maybe even more, things have evolved tremendously rapidly over these years. And if you were doing things, for instance, on E, which usually require a more standard approaches, right? It was impossible to keep up with the amount of innovation that was being done on the microservices world. Also, there was a little bit of negative perception towards the technology, especially because at some point, a big company, I'm not going to name here, but you probably know about, that was the stewardship of Java EE, was not putting as many resources to come up with that. And I mean, if you look on all the specs that you have over there, it was not really prepared for all these microservice deployment, right? When we're talking about health and do metrics and do tracing, right? All of those things were missing, and they needed to be added in one way or another somewhere. Also, we did this graph. So if you look on the E, so on E5 we have almost 20. We have 24 specs, and specs has been growing from each version to each version. But the interesting thing was, if you go from E7 to E8, they only added 2 more specs. So we can see that there was like a slow decline on new specs being added to E. Plus, we also seen that from 2006 to 2017, so that's roughly 11 years. If you count all the specs, I mean, they seem to be a lot. But if you split it over the years, there are not that many, right? And as I told you before, Microprofile only in a couple of 3 years, or actually 2.5 years, they came up with all of those specs really, really quick. Okay, so why Microprofile? Microprofile was supposed to be, or is supposed to be, a set of standards that are try to offer you a way, or opinionated way to how to develop microservices using Java. So Microprofile evolves very quickly to be able to answer the needs of these architectures. So that's why we're seeing a lot of versions coming up and a lot of new specs coming up as well. And the interesting thing about Microprofile is that this effort is actually a joint effort between the community, several vendors, and organizations that are collaborating to make this a reality. One of the things that I want to make clear as well is that Microprofile is not EE or Java EE, so it's, or Jakarta EE now. So it's, if you probably heard the news, some time ago it was renamed when it moved to, so when EE was donated to Eclipse and then was named to Jakarta. Probably you're also wondering what's going to happen now that they didn't come to an agreement to maintain the package naming. So that's another issue. But we're not going to discuss that here. But Microprofile is a set on its own, so you're free to use EE or Jakarta EE together with Microprofile, but if you only want to use Microprofile, you're free to use only Microprofile. You don't really require EE or Jakarta EE to use it. Okay, so now who's involved in Microprofile? So we'll see that you have some big companies here involved, like IBM, Red Hat, Oracle, and Fujitsu, and Microsoft, and of course Tommy Tribe, which John and John Lee represent. There are also some communities involved, so the London Java community is also involved. Anyone here from the London Java community? No? Okay, so I was hoping to get more people from the London Java community since we're in London. Probably makes some sense, but Maybe they're discussing Microprofile at this time. And also so Java Brazil, so it's another community of a Java user group in Brazil. And all of these actually came with their own Microprofile implementation. So, for instance, Tommy Tribe, they came up with Tommy, right? So that's the one that we're going to use today, but you have others. So Wildfly on Red Hat, IBM has WebSphere Liberty, and so on and so forth. So now Red Hat also has something called Quarkus that you maybe heard about. And all of those runtimes actually support Microprofile out of the box. So you can, if you already use them, you can use Microprofile. If not, you can look into them and start using Microprofile standard specs over there. Okay, so the one that we're going to show over here is going to be Tommy, but the interesting thing about Microprofile is, again, it's a set of standards. So everything we're going to show you over here, you are able to pick that up and run on any other server that supports Microprofile. That's the beauty of standards, right? So Tommy itself, as the name says, is actually Tomcat plus Java EE. So the name became Tommy. And it came from the OpenAPI community, which at the time was an AJB implementation to offer a lightweight alternative to Tomcat. And now Microprofile is actually implemented in Tommy 8, which includes all the specifications that I discussed over here. At the moment, it's only supporting Microprofile 2.0, but it's being worked out to support 2.2, which is the last version. But at least all the specs we're going to show, they are supported over there, just some minor changes here and there from these minor versions that are missing. Okay, so let's have a look on what will be my first Microprofile app. Oh, sorry, that's a little bit switch. Sorry? I mean, I told you if you have any questions, you can also interrupt me, but is there any questions so far? No? Wonderful. Yes, sorry about that. Probably that's a little bit boring part, which is the introduction, but we're going to start seeing more interesting things. So, CDI, I'm guessing, anyone knows CDI? Everyone, right? Wonderful. That's a pretty awesome spec, so I'm going to skip that. And of course, JAX-RS. You cannot develop microservices without JAX-RS, right? Maybe now we're going to have to rename it, I don't know, Jakarta EE. Does that work? Yeah, we're going to have to lose Java in there. And JSON-P. So for doing JSON processing, and of course JSON-B. So I'm going to skip that. You guys are already familiar with all of that. But now, if you look for this in this particular example, and you have here a resource, which is a book resource. So it's kind of like a bookstore, and I'm trying to find the book, and I'm returning a response. And of course, I have a get with a path and a path parameter to retrieve the ID. And then I'm just building my JSON object over here. Of course, I could have done it with JSON-B. I just done it like that to show JSON-P as well, and then return a response. I mean, does anyone see this is familiar? Okay. Does anyone have similar code on your project? Okay, not everyone, but maybe like 50% of the room. Well, congratulations, you have your first Microprofile app. Right? So without you having anything, without you reading anything differently, you already have a way to build Microprofile apps. So this is a first version of a Microprofile app. That's what you've already been doing. You're already able to run this on a Microprofile runtime. Okay, but that's not enough. Now we want to evolve our Microprofile app. So now we'll see we'll see how to use the specs that we mentioned before, and so we are able to leverage all of the Microprofile power to enhance our applications and add additional behavior that we usually don't have when we were doing that kind of sample. Okay, so we're gonna do like a very all the demos are gonna be around the same things, but of course showing different aspects of the Microprofile specs. And the idea is we're gonna have two microservices, one called the number API, which generates a random number another one called a book API. So it's a bookstore where you can do create, read, update, and delete books. And the number APIs is used by the bookstore to generate the ESPN number when you create one. So you query the number API to retrieve the number and create one. And of course, then we'll interact with those services using a gateway. Most of the cases we'll just call them directly. In some of the cases, we'll use a gateway, especially when we're doing security, to communicate with them. And then on the runtime, of course, we're going to use some of our laptops. But I'm not sure if you've seen these little pieces that we have over here. So maybe the people in the back are not able to see it. But we have here a bunch of Raspberry Pis. So one of the things we're going to do is we're going to package everything with Docker. We're going to push this to a local Docker registry. And then we're going to deploy a lot of stuff there on the Pis. And the reason why we're doing this is a lot of people were also telling me, oh, I want to use Node, I want to use JavaScript because JavaScript is so much faster and some other technology is so much faster. And I say, well, I'm able to run Java on the Pis. So if you're able to run Java on the Pis, that cannot be slow, right? Can you agree with me? Well, not everyone. Well, should I change the Node? No? I can run some Node code, maybe some Ruby code. Well, anyway, the ones that we have over here are Raspberry Pis version 3. They're not the last version, so there is a better version that came up maybe 6 months ago, which is a little more power, but they're mostly equivalent to Pentium 3 from maybe 15 years ago, if you remember those. And they have something very interesting, which is, I'm not sure if you heard about this before, maybe not. There is something called IPOS, and IPOS is an operating system designed for Raspberry, and is optimized to run Docker on an ARM. So it already has Docker built in, so you just have to flash the SD cards, put them over there, and then you have Docker, and then you can push whatever Docker image you have over there. There are some limitations, so basically the only limitation is that the Docker images have to start from a Raspberry image, right? Or a system that actually is compatible with an ARM. So if you pick up any Docker images that runs on your local boxes, usually don't run on the Pi because it requires an ARM, a ARM core. But if you don't have them, so these guys, the Rypriot, if you go to their GitHub page, they already have like images to run Nginx, MySQL, and a few other stuff. And the ones that you don't have, you can easily just make them very easily by just starting with an ARM Raspberry, and then you just add whatever you need over there. So for Docker, then we're using the Maven Fabricate plugin to create the Docker images. We usually we don't really like to use the networks conference Wi-Fi because we don't know what it's going to look like. So, and of course, Docker is super slow, so we don't want to go do push on the network and then come again. So we try to come up with a completely local setup. So we actually running a local Docker registry in our local boxes. So then we push the Docker images over there, and then we want to push them to the Pis. We just read them directly from our local Docker registry. So it will speed up deployment, and if we don't have internet or Wi-Fi, then at least it will still work, which is great. And finally, we'll use Ansible to automate all the tasks. So there are a lot of tasks you can do. For instance, you can ping all the Pis, you can deploy Docker images and start and stop. So if you're familiar with Ansible, there is a Docker plugin that you can use to actually push and run images to whatever system you want, including the Pis. And there is Ansible playbooks where you can set up all the tasks that you want to perform. Okay, so deployment is just going to look very simple. So for the people who are not able to see it, well, you can pick it up and you can just raise it as a trophy, right?
Please don't break it.
Don't break it. No, that's not going to work anymore.
Who's deploying their microservices on Docker at the moment?
Everyone, right?
Everyone? No one? Oh,
No.
2 people.
2 people deploying microservices on Docker. And what other deployments are you using? Amazon? No? Liberty? Oh, well, we can run Liberty on Docker, right?
Just pay.
Yeah. Maybe. Well, Liberty is quite big. We can try. Tommy runs there for sure. That's what we're running. So, if you're able to run Tommy over there and not able to run Liberty, you should change to Tommy. Okay, so the first thing, so we're going to go to the more interesting part, hopefully. So the first thing that we're going to show is microprofile configuration. So microprofile configuration, of course, every application requires configuration that you can set based on the runtime environment. I'm pretty sure all of you have come with these needs before, right? So even if you want to change, let's just say, the currency of the application, and you have multiple currencies, and when you have deployment on Europe, you have it an euro, and we have deployed in UK, you have it on pound. You're still going to use pounds when you leave Brexit?
I would imagine so.
I imagine. Well, maybe we'll just change to euro as well. So go Brexit and then move to euro. It will be fun. And the idea is that you can change the configuration without repackaging your application, right? And that's especially interesting when you're doing microservices, when, let's just say, you want to reach another service, you want to reach a particular endpoint, and you don't know when that endpoint is going to be, so you can set up that as a configuration value, and then you can just set whatever configuration you want. And of course, if you have things deployed on staging, you have things deployed on quality, you have things deployed on production, all of those paths and all of those configurations change, and you don't want to have to redeploy your whole application all the time. So that's the idea with configuration. So that's what we're going to discuss over here was based on previous projects that were developed on Apache. So Delta Spike config, and Apache Tamai and Sabbath. So those were some. Sorry about that. Those were some of the projects that configuration had some inspiration. And actually, configuration can actually be used standalone. So you can use it as a CDI. So you can inject stuff directly on your beans or in your services, or you can just call a particular API without any CDI, and you can just use it completely standalone, which is great. So it supports default values and supports the most common Java types, so strings, integers, longs, and even supports optional. So let's just say the configuration is not there, so it returns you an optional, and then you can do whatever you want with it. So very simple way to do it is you set up a property, you say at inject, you say at config property, you pass in the name of the configuration, and you can set up a default value. So in this particular case, I'm just saying that's the target URL for me to call the number API, and that's the target API. And if I don't set one up, I can just put the default one over there. And this will be the equivalent if you don't have a CDI environment. So you can say config provider get config. You have a config object, and then from that config object you can say config.getValue. You pass in the configuration property, and you can say what should be the return type. You can also say get optional value, and of course you can also pass in a default value over there if you want to actually retrieve a value. Now, the interesting thing about configuration is something called config sources. So the actual spec already comes with free config sources. So we call it the free default config sources, and those are that file called microprofile.config. So that's usually packed on meta-inf on your application, and it works at any property files like key equals value. And it will mean that microprofile config can read configuration from there. But there's also system properties and environment variables. So that will mean that you're able to pass in configuration using -d, when you start in the JVM, or when you set up environment variables on your machine, either a physical machine or even a Docker container. So you can set up environment variables on Docker container, and the idea is that you were able to override stuff depending on when you define the configuration. So usually what happens is the config properties have a priority, and they follow a priority which is, so first it will start to find stuff on environment variables, and if it doesn't find anything, it will go to system properties, and if it doesn't find something, then fallbacks to microprofile.properties. And this is not for everything, so it will kind of like merge everything together. So let's just say you have the same configuration on all three. So usually the one that wins is going to be the config source with highest priority. So environment variables.
I think we have a question at the front.
Oh, yes? No, this is pretty standard. But I have another solution for you. I'm going to... The question was, can we configure? Oh, yeah. So let me repeat the question. Sorry about that. The question was if we can change the location of the config file. The answer is not this one, but there is a way to actually create your own config sources, and you can set up on whatever priority you want. And of course, nothing's stopping you to have a new config source going to read the file from somewhere else and load the configuration from there. So to end up this really quickly, the idea is that you use these as fallbacks to configure stuff. So you can start up with all the default configuration of microprofile config.properties, and then if you want to change the configuration, you can just, for instance, use an environment variable, and it will change the configuration without having to repack your application. Now, I'm going to start doing a couple of demos over here, which is going to start on the more interesting part. So let me sit over here. So the one I'm going to show you now is I created here a database config source. Are you guys able to see this properly? Or do you... Bigger? Let me see. Well, I only have presentation mode. Do you guys prefer black or white? White? Okay. Let me change that one. Is that better? Okay. So you have this interface called config source, which you can implement. And what I'm doing over here is I implemented a config source called database config source, which is going to retrieve configuration values from a database. So I'm just retrieving here where I have my database. And there is if you look over here, there is a few methods that you have to implement. So the get properties, so it will load all the properties you want to do in a map. So remember I told you it's a key value format. And then you also have a get value and get name. So get name to retrieve the name of config source, and the get value to retrieve a specific value from a configuration. So and what you'll do over here is so I implement my get properties. You'll see over here that I'll create a connection to connect to my database. I do a select to retrieve the configurations from a table called configurations. And if you see over here, so I mean the configurations is not that, it's pretty basic, right? So it's just a table with a name and a value. Then I'm inserting here a configuration on the database. So let's go this again, and you also have the get value, and you may notice why you have something called get properties and another get value. You might say, okay, I could just grab all the properties and then have a cached map, so I don't have to retrieve them again. So the idea is that you can also do dynamic loading. So Instead of caching values, you can just retrieve the value to have the last updated value. So that's something that you have to choose which one you want to do. And then just the name, nothing really fancy. Finally, you'll use the service loader that's specific on Java. You pass in the fully qualified name here on the meta-inf services. So you can set up what's the config source you want to load. And I think I forgot to tell you this. So here is a priority. So I return as a 500. So if you see over here, you'll on the priority methods on the Java doc. So you see that the default. Let me see. I'll go over there. It's probably easier. Okay. So you'll see the ones that are already shipped. You already know. They'll tell you what the ordinal is, and the idea is if this value is, for instance, is 300. So the more higher the priority is, the more value, or the highest priority will be to load that config source or to load that configuration value from the config source. So when I set that as a 500, it will say that it will always try to look first on the database, and if it doesn't find anything, it will start fall back to the other ones. So now I have here my number resource, which is the endpoint that I wrote to generate a random number. So you'll see over here is nothing that fancy. So just do a math random with a floor. And what I actually have over here is I have a config property that tells me what the prefix of the number is going to be. So I have here multiple prefix. So I'll say undefined, book, movie, CD. So for this to generate different IDs depending on the object that I want to create. So if I run that one, so let me run it like that. So here now I'm just running with Tommy Maven plugin. It will run the application as you'll see over there. Okay, there you go. So I can just, are you guys able to see this properly? Okay. So let me do localhost 8081 and let me copy the endpoint from here. Well, number API, numbers. Okay, that should be it. Numbers / generate / guest. Well, now you got a random number over there. Let me put that a little bit bigger. Okay. So if I call that multiple times, I have different numbers, nothing out of the ordinary. Okay, now what I can do is I can come here to my script on the database, and I can change these to something else. Let's just say, let's see what we have on the prefix, movie. So we can change that to a movie. Okay. So let's restart that so I can run that script again. So I'll probably have to do a clean. Well, I'll have to get rid of the database. So. I'll do it like that. Okay, so if I call this one again, now you'll see that the prefix changed to MV, right? Yeah, I mean, it sounds a little bit troublesome because, I mean, I have to change here, but of course, because my database is running on in memory, but if I have actual database, I could just go over there and do an update, and then I can reload the application, and then it will reload the configuration. But the idea over here is, let's just say, I could remove this, and I can probably now start doing export on the environment variables, and that will be it. So I'm not going to, you get the idea, so I'm probably not going to use more time on that. Another thing you probably notice is if you look here in the number resource, you'll see that what the thing that I'm injecting is actually a different object. So it's not a native object. It's not one of the objects that we're used to. So it's an enum. So for these particular cases, configuration also has something called the configuration converter. So you'll see over here there is something called converter, which implements an interface called converter, and also has a method called convert. And basically it will retrieve the configuration value as a string, and then you can convert it into any object that you want. So instead of injecting a string or a long or whatever, you could inject it as the actual object that you want. So in theory, you can actually use it to have composite objects separated by commas or whatever, and then you can create the actual object depending on what the conversion is going to be. But you have that option, right? So you also can convert objects from the configuration to whatever object you have. Yes?
When I use environment variables as a source, and I'm using the declarative approach with the annotations, then the values are taken from the startup, right?
Yes.
And when I use the programmatic approach, then I get the current value, whatever it is currently?
Yes. So the question was, if I use, for instance, environment variables, if I'll get so basically when I'm loading the application, if I load the application, then it will read the environment variables as they are when I run the application. And if then I use a programmatic approach, it will read the environment variables as they are at that current state. So the answer is mostly yes. Now, there are differences in the implementation where you actually have a configuration where you can say cache the values when you start the application, so you don't see those differences, right? So depending on the use case, because there might be cases where you actually want to have a dynamic loading, right? And there are cases where you want to actually lock the variables on start. So it might depend on your use case, right? But you have both options. You can say, I want to dynamically load the values all the time, or I want to lock them in on start, and do it that way. So the actual default is, I think it will lock the values on start, and then you require the configuration to dynamically load. Okay, and that's I think that's pretty much it with configuration. So the idea is you can inject configuration, have defaults, you can create your own converters, you can create your own config sources. So config sources can even be something calling to a database, like I showed, but it can be like a file. So you have that other file which has matter.inf. So maybe it's not on the location that you want, but you can create your own config source and read to another file. Maybe you can even create a config source to call other APIs and retrieve values from other APIs. So now you just use your imagination, right? But it's very flexible, and it's you can use it to do a lot of different things. And now, actually, let me show you that running on the Pis. I mean, it's not really that difficult. So one of the things that we do over here is, so let me run that fully. So now we're running that with the Docker build, Docker push. So it's going to start. It's going to create the entire application. So the Tommy Maven plugin, one of the things it's going to do as well is going to create a fat jar that you can just execute. So at this point, I was running with the plugin itself. I can just show you how to run the jar as well. So let me show here in a sec. And what we have done over here is we created Docker images based on that jar. So we can just run as a Docker image instead of the jar. But if I want to run the jar, I can just do java.jar, and then on the target there is something called number API exec. And now it will run the exact same thing that I've just run with the Tommy Maven plugin. So now you have the application, and if you do the curling, you still have the result. Now you can do like an Ansible deploy over here. I'm not going to do that because it does take a little bit of time. But what I can do is I can do a curl on something called pygram database. Actually, let me do a cumbersome server 1. And you'll see that the endpoint that I'm calling is very similar to what I have over here, just the host that changes, right? So if I do a curl over there, now I have a BK. That's how it was set up on the Pi. So let me call a few others. So John Lee is trying to disconnect stuff over there. Let's see if that works. Now it's not giving any answer anymore. Does that make sense, right? Because there is no cable over there. Do you agree that I'm running that on the Pis? Are you certain that I'm running stuff on the Pis? It does seem so. Can you connect the cable again? Let's see if we get a response back. Not sure it's going to be able to recover. Let's cancel that, but if I call that again, there you go. So I can do I'll just do an SSH so you can see how the Pi looks like. Should be like that. Oh, you have it. Those Pis are different than mine. Yeah. So you'll do the SSH later. Never mind. Yeah, then it's going to mess my entire host file. Doesn't matter. Okay, so let's move to the next one. Then John will show you how to do SSH. So the next thing I'm going to show you is microprofile fault tolerance. So how about fault tolerance? So fault tolerance allows you to have different strategies to guide the execution result of a piece of code. And it's heavily inspired in Easter eggs and failsafe. Who heard about Easter eggs and failsafe before? Okay, most of you. And well, it does support async and async execution. So the idea here is you'll use fault tolerance to do stuff like circuit breakers, retry, timeouts on services, and so on and so forth. So I'm going to show examples on all of that, and I'll try to go step by step on each one of them. Now, fault tolerance itself is heavily dependent on CDI, so unfortunately you're not able to use it as standalone, so you do require a CDI environment to use it, because it uses interceptors to intercept what you're calling, and then apply the behavior on your method, on your business logic that you want to execute. But it does integrate with microprofile metrics and config. So one of the things that's also interesting on microprofile is that then all the specs start coming together, and then they'll start to integrate with each other. So one of the things they can actually retrieve with fault tolerance and metrics that John's going to show you later, well, probably not the fault tolerance part, but then you're able to see a bunch of metrics of endpoints that failed, things that fall back to another endpoint, things that have to retry, and so on and so forth. Okay, so I'm going to start with the most simple one, so timeout. So the timeout allows you to prevent the execution from waiting forever, right? Especially when you're calling, let's just say you're calling a service that's super slow and you don't want to wait for the entire time for that. You can just say, okay, if the service doesn't answer me in X amount of time, then I'm just going to kill it, or I'm just going to drop it, drop the request, I'm going to drop the call, and we're going to do something else. And I think it's very useful, especially in that particular case. So for a timeout, what I'm going to do over here is, so let me show you a little piece right now. So I have my number API, as you've seen, which is this number resource which generate numbers, right? And now I have a book resource as well. And if you remember, I told you that on the book, I was going to call the number API to retrieve a number I'm going to use as the SBN number of the book, or as an ID to the book. So now on my book resource, I'll have a few methods that I'm going to use to call the number API to retrieve that. So if I show you here really quick, so I have my number service, and then I'm just using here, I just inject the number API target. So there are other techniques how to do this, but I'm just using a very seamless way how to do it. And then there is this method called getNumber, which is going to retrieve the number calling from here, and basically has like a web target for me to call that number API, and then I can pass in that endpoint and go forward. So to make it a little bit easier, I just created multiple versions of the number API call with all the different annotations and all different behaviors that I can add with fault tolerance. And for instance, I have here with timeout, so I'll say that my timeout is going to be 500 milliseconds. So usually the values that you set up are always in milliseconds, but the annotations usually also have a way where you can say maybe 500 days? Well, maybe not. But the defaults are milliseconds, right? So in this case, it's going to be 500 milliseconds. And maybe you will notice that in my number resource, because generating random number is so slow that I have to create a sleep of 1,000 milliseconds. So what do you guys think is going to happen? So let me start. No, that's not the curl. So I'm going to start the number API. So let me curl that one. So not here. So it's number API numbers.
I think you need to change the port number on that as well.
Yeah, that's 8081. Wonderful. Generate test. Okay, so now I have numbers over there, and you'll see, creating this number is so hard that it takes a while. And now I'm going to call that from my book. So let me start the book. So I'm going to run with the plugin over here. Now the endpoint's a little bit different. So number, I'm going to do timeout. So now my number API is running. My book is going to call the number API, but I have a timeout. We know that number API takes 1,000 milliseconds or 1 second, and I'm waiting for timeout to be 500. So when I call this, I immediately get an exception, right? Because now if we look a little bit in the exception, it will say timeout exception, and that was because I was calling an endpoint or a resource that took longer than the timeout that I had. So it will just interrupt the call, and it will just drop it, and it gives me an exception. Then, of course, I'm free to do whatever I want with it. So that's timeout. Now retry. So retry is about you want to invoke the same operation again. And the idea is, let's just say you might be on an unreliable network, or you want to recover from whatever glitch you want. So you can set up your endpoint to actually do a retry if it fails. And you can set up the way it will do the retries and how many retries it will do and how much time it's going to wait for each retry. So that's the idea. So even if it fails, it's going to retry a couple of times, and then if it's not able to successfully call the service, then of course it will give you an exception. So for the retry, let's show that one. So again, I have my book resource over here, and I have this one with retry. So on retry, I'm setting that I say I'm going to do it by 5 times with a delay of 1 second. Jitter over here is a random value that you set up. So I have set up that at 0 to be more predictable. Let's just say if you have 200, what jitter is going to do is going to add or remove 200 milliseconds to the actual delay. So it doesn't make requests with the same timing all the time. So let's just say it can be, the next one's going to be 1.2 seconds, and then the other one's going to be 800 milliseconds. So that's the idea. It's random. And I can say it's going to retry on a runtime exception. So those are usually the things that you want to set up. But there's also a max duration. So you can say what's the max duration of the entire thing. And I'm actually combining these with the circuit breaker, which I'm going to also explain. So the circuit breaker, so let me actually put here on the slides, probably easier. So the circuit breaker is something that's used to prevent repeated failures, right? So if you're calling an endpoint that's always failing, right, you don't want to, especially when you have a timeout or you have to figure out that actually failed, you don't want to have to call that all the time, especially if, let's just say, the service is under a heavy load and it's failing because it's not able to handle the load, then keep sending more requests, they're not going to help him, right? So the circuit breaker allows you to break the circuit and fail fast, so it doesn't call the service. And then what the circuit is going to do is it has multiple states. So it usually has open state, a half open, and a close. So usually the circuit breaker starts as a close. So it's kind of like a light switch, right? You go there, you switch the light switch, and it means that you close the circuit, and then you have light. So the same thing you can apply to the circuit breaker. So it becomes half open when you have, or it becomes open when you have a few failures, depending on the configuration that you set up. And basically it will fail fast, doesn't call the service anymore, and just going to return a failure. And then it will become half open, depending on the settings that you set, and it's going to try to call the service a few times to see if the service is able to respond. If it is, then it will go to close again. If not, then it will be open, and then it will go to the next rolling window to retry stuff again. So let me show you this a little bit, because I think that the retry with the circuit breaker actually work well together to show stuff. So I have here my endpoint. So I'm going to do retry. And you'll see here, actually, I got one, and that's fine because my number API was running. But now I'm going to kill it, and I'm going to run the retry again. So now you'll see I have a couple of exceptions going. So it did retry, but it's not able to grab some. And now you'll see that still got the connection refused, right? Because the service is not available. So let me call that a few more times. So you notice there is a little bit of delay when I'm calling the retry, because it's the amount of retries is doing on those seconds. But now you'll see that's instant. Now it starts to be instant. And it starts to be instant because now the circuit breaker kicked in, and now if you look on the endpoint on my logs, now you don't see the connection timeout anymore. Now you'll see a circuit breaker open exception. So now I keep calling it, and it's instant. So let's see actually what we're doing over here. So on the circuit breaker, we'll say if on my rolling window of 30 seconds, I have a failure of 0.75 on a request volume threshold of 4, so that will mean on 30 seconds I have to have 3 failures, then the circuit breaker will open. And then also see that on such threshold will mean on that rolling window I'll have to have 2, after it will be half open, I'll have to have 2 success calls to be able to close the circuit and have it running again. So now probably the 30 seconds are up, so if I call that one again, now you'll see that also is getting a little bit of delay again. But the circuit was not closed. It was half open because it was trying to call the service to see if it was better. It was up again. So now it's already failing fast again. Now if I start my number API, so let me keep calling retry. So now it started. Now you got it, right? So now it was able to detect the service was up. Now it's retrieving the number again.
Is it shared across threads?
Yes. So depending on how you set it up. So there is an async annotation that you can use, and when you use an async annotation, it will use its own thread. But when you don't have that async, it will just use the thread that's running on. If you're using async, is forking the thread local variables? That's a very good question, which I don't know the answer. But I'll have a look. I will speculate that it won't. Okay, so let's see other things over here. So we look in the circuit breaker, look into the try. Now the fallback is something that you can use to invoke when the original execution failed. And it allows you to fall back to another piece of code. Let's just say I can do it to generate another number instead of relying on the number API to generate that. So to show here the fallback super quick, I can now say fallback, and the fallback, of course, gives me the number that I want. But if I go over here and I kill the service, and I call fallback again, now I get the fallback number really, really quick. So it works in this way. So I annotated with the fallback. I said that there is a number fallback handler. This fallback handler implements a fallback handler interface, which is a method called handle. And on the handle, I can grab the execution context. I can do whatever I want with it. But in the end, I just want to return a fallback number if I failed, if my endpoint failed. So in this particular case, even if my endpoint is down, I can still call it and I have a number back. So maybe it's not the best choice for a number name, fallback number, but for you to see the change. And finally, so I talk about circuit breaker. Finally, I want to show you is the bulkhead. So the bulkhead allows you to limit the concurrent requests on your services or your endpoints, especially if you're accessing them on multiple contexts. And the idea is that you can use them to prevent all the failures to cascade. So let's just say that you're calling an endpoint that's doing heavy work and it has limited resources, right? So if you're calling it with multiple requests, then you keep calling, and then it's not able to handle the load. So usually the best technique is you actually have to put it in a way that is able to handle the load, but if you're not able to do it, the bulkhead might be a good solution for you. So the bulkhead, how it works is, let's see. So again, you can annotate this with the bulkhead, and in this particular case, what I'm doing is I'm saying that when I'm calling these methods, I can only have 3 parallel executions of these methods. So to simulate that a little bit, I put like a sleep over there of 30 seconds. So now what I'm going to do is, so I have my book, so I can call this number with bulkhead, and I'll see that's waiting over there. So I'm going to have a couple more windows. I'm going to call bulkhead. I'm going to call bulkhead again. You see, still waiting. Now, when I executed the 4th one, it immediately returned with an exception. See, because I only accepting 3 concurrent requests, and I'm already using the 4th. So you'll get something like fault tolerance exception, bulkhead exception, no more permissions available. So there is no more spots for you. And then I'll be able to call the service again when the other executions are over. You also have, I haven't showed that here, but you also have a way to set up a waiting task queue. So you can set up concurrent requests, and then you can create a queue. So if I have like 4, I can still call the service, but those will be waiting for the endpoint. And of course, when it gets to 7 or actually 8 requests, then it will fail the way I showed it. And this pretty much concludes what I have to show you about fault tolerance. So one of the interesting things, again, about fault tolerance is I'll show you all of these annotations separately, or at least, for instance, retry and circuit breaker, they were combined. But you can actually combine all of them together. So you can have something which has a circuit breaker, which is a retry, with a timeout that does a fallback if it fails, and has a bulk has with concurrent requests. So you can combine all of these, and you can create specific configuration and specific executions for your endpoints or business methods to configure it that way. Okay, so.
All right, should we swap this over?
Yes.
Hopefully this will work okay. Okay, awesome. So I'll give you a talk through the Microprofile health check specification. This is a relatively simple specification. And it's useful because, typically when we deploy services, we might deploy them across a number of different nodes and put load balancing technology in front of those nodes. And so, we need to know, the load balancer needs to know whether the nodes that it's balancing across are healthy or not, so that we don't end up in a scenario where we end up sending traffic to a node that's potentially in a bad state. There's various different ways that load balancers might achieve this, so they might just try and create a TCP connection to the socket that the service is publishing and seeing if it can get a connection okay. Or you might be creating something that's providing a ping mechanism with a specific endpoint that you're putting inside your application. But what this specification does is it attempts to create a standardized endpoint that you can call to get a view on the health of your service. So, like you'd expect with Microprofile, it's based on CDI and JAX-RS. And very simply, if you do nothing with your application, it will provide a health endpoint. So as your application gets deployed on the server, Microprofile will add the health endpoint in there, and you'll be able to start calling that without adding any code into your application. We get information back from the health check in a couple of different ways. So first of all, there's the response code. So if everything's running okay, you'd get a HTTP 200 response, as you might imagine. And if there's some issue, then we return back a 500 error response along with the details of exactly what's gone wrong. The payload itself is very much everything is up and running okay, or the service is down. But we can include more detail within the health checks as well. So just providing an up or down, just whether the service is running or not, can we accept the connection in and run through a JAX-RS endpoint? Maybe not terribly interesting, because that might not actually give us a particularly good view on the complete health of our microservice. So our microservice might be calling other microservices, or we might be making a call out to a database or something like that. So we're also interested in knowing, are we able to get a connection to the database? Do we have enough connections in the pool? Are the services that we're trying to run, are they available, or are they experiencing some problems? So the health check specification provides a nice way whereby you can create your own health checks and add them into your application. So the example that I've got on the screen here is how we would lay this out. So if we imagine that we're doing a disk space check on the server, in essence, we create an application scoped CDI bean, annotate it with health, and then this needs to implement the health check interface, which just has a single method on there called call, and then the health check response object we need to construct and send back. And so this has the name of the specific health check along with its state, whether it's up or down, and any metadata there as well. So I'll give you a little demonstration of a custom health check that we've got, and we'll try giving it a call so you can see the information that you get back. Okay. So if I make a call, if I flip over to my terminal here, and if I just do a curl, oh, how's that? Is that readable? Okay. I'm hoping that's going to work. Ooh. Okay. I've got some demo gremlins somewhere. No problem. I'll just start the service up locally. In fact, I might even have that running. Okay, fab. So you can see here, this is just an out-of-the-box service that hasn't got any health checks added on. So you can see we just get the overall outcome status, which is that the service is up. So in our number service, we've added in a health check here, and I'll just try and make this text a little bit bigger. IntelliJ's going to let me. There we go. Can you see that okay? So we've got our check audience isn't sleeping health check. And so this is just a very simple example where we're actually just generating our state is random here. Okay, so you can see we have our CDI bean implementing health check, and we're just creating a new health check response here, picking a random state, and then returning the name and the state itself. So this particular method is called synchronously when you invoke the health endpoint. So this object that you return here needs to be immutable. Okay, and we can also add in just a map of data that we want to include in our payload if there's more information that we want to put in. Okay, so if I give this a call. Okay, so we're okay at the moment. And then you can see in this particular call we're down. The overall status, the outcome status, if any of the checks that are performed when we hit the health endpoint are down, then the overall status will be down as well, even if other health checks complete successfully. So you need to inspect the various different checks to get the full status. Okay, so and there's an example payload where we've got some data that's included there, so that gives you an idea of what the payload looks like with the extra metadata in there. So that's pretty much it in terms of the health check stuff that I have to show you. I don't know if there's any questions just before I move on and talk about metrics. No? Okay, I think we're good. Okay, so metrics is a little bit similar to health check, but it's a different specification. Again, it's a relatively simple specification. The specs themselves, I find, are worth having a read from Microprofile. They're fairly easy to digest. They're quite short and take you through examples where appropriate. So this the spec gives you quite a good view on everything that's going on and gives you example payloads and things like that. So it is worth a look. Okay, so metrics gives us the ability to basically monitor what's going on through our application and actually get some numbers behind those. So we can use this to ensure that our software is running reliably. So we can actually gather these metrics up periodically, and we can do things like we can create management reports from those. We can generate alerts. So if we see that something is starting to take a long time and maybe needs some intervention, we can go and we can gather the metrics and send alerts off for those. We can see if we're breaking SLAs, for example. So in a similar fashion to the health check API, metrics are accessed via a REST interface. And there are 3 different types of metrics that are available. These are broken up into the base metrics, which is a set of system metrics that every single microprofile implementation needs to provide. And those are documented in the specification. So you can be sure that if you're collecting memory details, for example, through the metrics interface, when you do that in Tommy, you're going to get the same type of output that you're going to get if you were doing that on OpenLiberty, for example. There's a vendor area, which is for server-specific metrics, but those will be dependent on the particular vendor that you're using. So each of the vendors are free to implement their own metrics and add them underneath that area. And then finally, there are the application metrics. So this is your opportunity to go and fill your application with metrics that are important to you and collect those numbers, and then they're made available under /metrics/application. So calling each of those endpoints will give you the set of metrics that's available in each different group. You can also use an options request. So rather than doing a GET request against the metrics endpoint, you can call options, and that will give you the set of metrics that are available, their description, the units of measurement that are used for those particular metrics. So you can pick up all of the metadata behind them by calling options. So calling metrics gives you a payload, and it actually comes back in 2 different formats. So here you're seeing the JSON format. It can actually return them in a YAML plain text format as well, which is compatible with Prometheus. So you're able to point a Prometheus server directly at the metrics endpoint and start pulling data from your various different servers. So here we have a sample call for using the options verb, so you can see the various different elements of metadata there around our metrics. So one of the useful things is you're gathering metrics from your own application, and there's a number of different types of metrics that you can add into your application quite simply. So counted provides you with a simple counter. So I'll take you through some sample code, but basically if you annotate your method with counted, it'll keep a counter that increments every time your method is invoked. Metered provides a way of gathering, in effect, how the rate at which your method is being invoked. So we can get a view on how many requests per second you have going through your method. Timed is similar, but gathering how long the method invocation actually takes. Gauge provides you with a way where you can just provide information. So if there's a particular value that you want to provide, so for example, if your application processes things from a queue and you're interested in knowing what the length of the queue is, you can create a method and return the length of the queue and annotate that with @gauge to get a value back for that you can then monitor. And histogram also allows you to collect values, but it keeps track of the change of those values over time, and you can get some statistical information on there as well. That one, I haven't got an annotation on that one. That's a little bit more tricky to use because you have to create the annotation and register that with the metrics registry. So let's take a look at a method that's got some metrics on it. So you can see on my JAX-RS resource here that I've got metered and timed on some of these methods. Sure. Thank you for shouting out. How's that? Can you see that okay at the back? Perfect. It's a little bit long, but hopefully you get the idea. So on this particular method, find by ID, I have I'm collecting that on a metered basis as well as timed. Okay, so I'm tracking I'm tracking the rate at which this is being called and also how long those calls are taking. So hopefully, if I flip over to Prometheus here, so I can pick up the various different metrics here. If I do a quick call, so that's what that's the output that's coming from the endpoint that I have Prometheus configured in my environment to pick up. So Prometheus is going to keep continually polling this endpoint and gathering all the data, and then I can then say, right, okay, this is what I'm interested in looking at. Yeah. Oh, sorry, we've got a question. Go ahead. It's very simply using the accept header on the request. So you can say accept text plain or accept application JSON. So just for the benefit of everyone, the question was, how do you change which format you see that data in? So you can just specify what you want with the accept header. Yes. Yeah. So there's nothing that you need to do in order to support Prometheus. That's part of the specification. So we have to provide the metrics in both formats. Go ahead.
Can you also push the metrics to a database or to an event?
So the spec itself is a pool basis. So what you're looking at when you invoke the endpoint is data as it is at the moment where the endpoint is called. But you can store that in a database. So Prometheus that I've got running here will keep track of that over time. Yep. But it's different to the application server itself actually keeping those events and actually pushing those to a HTTP endpoint. So I'm not aware of a way to do a push from Microprofile as it stands at the moment. Oh, well, you mean from like the stuff that we've worked on?
The metric, you could push whatever you want from there.
I guess you could. I mean, the idea is that you're really returning, you're annotating a method, and then that's being held in the metrics registry, which is then ultimately what's making up that payload when you call the endpoint. So if I do a find by ID here, So let's take a look at one of these. No data. Okay, I think my connection to my Raspberry Pis has decided it's not going to like me. So I'll carry on and try and we'll have the break and then we'll come back. So let me just flip back to. Let me just finish this off. So one of the other things that I've got here. So in addition to adding annotations onto methods, you don't necessarily have to stick with the sort of method level granularity. You can create metrics and inject them. So for example, here I've got a timer called requests that I've injected into my class. And actually every method inside this class is making a call to that metric. So each one is saying, time this particular bit of code. And so I can actually gather something where, in effect, the calls to all of those methods are aggregated together in one timer. So, if you want to just capture, part of a method call, then you can do that. Or if you want to aggregate lots of things together, you can do that as well. You've got the flexibility to do that.
So
got a question?
The environment-based information, like if you're running your application on a staging, or development, or production,
Yeah.
how do you include that information?
So you're looking to include some of the configuration information in the metrics themselves.
Yeah, if I'm running my Docker instances on AWS, then I would like to know, what's the availability zone, or what's the environment, and if I do have some custom parameters, then how do I?
Yeah. So you would. I'm trying to think how that would fit into a gauge. So where we actually pull the data from, for example.
I mean, not necessarily gauge, but some other timed or, how does it,
Yeah.
In production, how long would it take for a method to return a response in compared to development, where I would be having...
So you maybe have different hardware or different availability zone, for example.
Yeah.
Can I come back to you on that and give you a better response in terms of collecting that metadata? Perhaps have a look at some code at the end of the session. Would that be all right? Okay, awesome. Okay, so I'm kind of conscious that I'm going over a little bit, so I'll just run through some of these requests on the slides. So just to give you a flavor for the different metrics themselves. So with the meter, we track the request rate and broken down into different periods, so we can see how this is changing over different periods of time. So you get the 15 minutes, 5 minutes, and 1 minute. So you can, if you're looking to see is something slowing down, or are we getting fewer requests coming through, you can look at these statistics here to get a view on that. With time, again, we have the sort of 15-minute, 5-minute rate, and then we also have the percentiles. So, if you have an SLA that says, 99% of the requests need to complete in this period of time, that's something that could potentially be useful to you, so that you can trip an alert if you see that things are going outside that. Yes, sir. Yep. So the question there is, looking at the sort of aggregate of requests, because you might have this going across several machines. Is that right? So you'd be seeing that this output on a per node basis. So there's not sort of magic to sort of gather that across the cluster and present that as one value. So you'd be sort of seeing what the performance would be for each node. It's really focused around providing sort of the standard format for the payload. One of the things that's worth remembering is that this is a standard across the different servers. So if you have an environment where, say, you have some of your services are running on, say, Tommy, and some are running on OpenLiberty or Wildfly, for example, you're going to get the same kind of payload from all of those, but they don't necessarily have the means to sort of talk to each other to aggregate that together. Now, the thing that's pulling the information, it's not specified what that is because the client for this endpoint can be whatever you want. But there's nothing that says that they can't aggregate that information together and present that as one value for you. So it would depend on the product that you're using to actually read these metrics. Does that make sense?
I was just asking this because actually using the product for aggregation would overlap doing those calculations.
Yeah.
And it's, despite being very light, it's CPU that is wasted.
Yeah, for sure. No problem. So counted is fairly straightforward. I've just given an invocation count coming back. And then for a gauge, this is the sort of thing that your custom gauge in your code would look like. So you can see here, in this particular case, I'm tracking a number of books that have been added through the book resource in an atomic long, and at any point I can go and I can get that value through the metrics endpoint. So this is possibly more useful if you're getting a queue length or you're interested in some information in terms of how big, how many connections you have available in a connection pool or something like that. Okay, and again, the payload is very similar to the counter there. Histograms, they're a little bit more tricky to work with because you can't just add histogram, but you can create them using the same sort of inject metric syntax that I showed you in the code earlier. And then you can just update them periodically in your code to provide new values. And that provides quite a big payload, so it keeps a set of statistics along with that as well. So we kind of come up to a bit of a break. So how long is the break?
Half an hour.
Half an hour, okay, and then we'll come back and I'll run through OpenTracing. Welcome back, everybody. So I'm going to just talk through the OpenTracing specification. Ignore the break time. So OpenTracing allows us to basically trace requests as they come through our application, and it's distributed. So we can actually trace requests as they come into services, and that service calls onto other services that make up the application. The way that this works is we build on top of a specification called OpenTracing, and OpenTracing provides a vendor-neutral way of collecting this data and pushing it to a database to track the information. So there are a few different suppliers. So we'll be looking at Zipkin today, but there's some others. So there's Jaeger is another OpenTracing provider. So with OpenTracing, it's the spec sort of focuses on tracing JAX-RS calls. It's on by default, so JAX-RS calls that come into the system, we trace how long those take to make, and if you're then making ongoing calls using the REST client, which we'll talk about a little bit later, those calls are instrumented, and the trace information is then sent as HTTP headers through to the service that's being called. So if you're interested in this kind of thing, it's typically these headers here, so the XB3 trace ID, XB3 parent span ID, and XB3 span ID are the headers that get passed around between the service calls in order to keep track of what's going on. And everything's pushed through to a database, like I mentioned, so you can query that, and the idea is that you can say, right, okay, for a particular call I'm making, pick up the information about the various different things that are being called as part of that overall request. And so this is useful if maybe you have something that's running slowly, but you don't know whereabouts in your system you're seeing the bottleneck. By collecting this trace information, across all of your microservices, you can sort of pinpoint exactly what's going on. So there are a few things in terms of concepts in OpenTracing. So we have spans and traces. So a span is in effect an operation. So a particular JAX-RS call, for example, would be captured as a span, and all of the spans together make up a trace. Spans have parents, so we can see one particular span calling another span, so we can see the call hierarchy through our system. So just a little bit of a recap on the application that we're looking at. So we have two different services. So we have our book API, and that's making a call off to the number API to supply an ISBN number. And we're making calls into the book API. We do have on our setup, we have a simulator, which is a JAX-RS client. So we're able to extract some information from that as well, so we can actually go from the simulator through the various different service calls in our application. So JAX-RS calls are actually traced by default, as I mentioned before. You can turn that off if you wish to do so. So you can add traced onto a method, and you can say and you can set that to false to say I don't want to trace this particular method. If you want to trace methods in CDI beans that your JAX-RS calls, you will need to add the @traced annotation onto those methods or onto the class if you want all of the methods traced. But the traced annotation itself is very straightforward. There's no other information to put on there. Okay. I did mention the OpenTracing API. Okay. So you're able to actually use the OpenTracing API in conjunction with Microprofile if you wish to do so. So if you're only concerned with looking at JAX-RS calls and invocations of methods on CDI beans, you don't need to do anything more than use the @traced annotation. But if you're interested in being a little bit more granular, so you're interested, say, for example, I want to just track this part of a method, and I want to put that into its own span and see, what the invocation time of that is like. That would be a sort of a use of the OpenTracing API. If, for example, you wanted to track a database call, that might be another example where you might just want to wrap some code with some OpenTracing code. So on the board here, you can see what we're doing here. So this is the key bit about how we get a hook into OpenTracing. So we can inject a tracer object. So this is available to your application. And then on that tracer object, we can then say, right, okay, we want to grab the active span. We want to create a new span here called create. So we give it a name. This is effectively our operation name. If our current span isn't null, then we want to make our new span a child of the span that's currently active. Okay, so this is how we create the sort of hierarchy of operation calls. And then we can also, if we want to, we can attach some metadata onto the span as well. So here I'm just adding a created is true. but you can create as many tags as you want. And so that can actually make it quite useful to actually find elements of your request as you're digging through your requests in Zipkin, so you can search by these tags. You might also want to sort of, provide that information, so, if you're doing some particular thing, you might want to just add some particular data there, so you might always see that, this call is slow in particular circumstances, and you might be picking up that information by what the tags that you're applying on that span. And then finally, we're then going to activate the span, do some work. So in this particular case, we're creating a book and adding it to the database. And then finally, we're going to say, right, okay, we've finished. So it's a little bit long-winded compared with just putting the trace annotation on there. But the API is available to you if that's something that you wish to use to wrap things that you wouldn't be able to do with the @trace.
Is this what I would do for SOAP part?
Quite possibly, yes. Unless you just have your SOAP call in a CDI method where you can just put @traced on the top.
Okay.
Yeah.
Vertical methods, so I don't need to
Yeah. So the thing with your SOAP call though is that what you would be tracing is just the invocation of that method of code. So you then wouldn't be propagating the headers to the thing that you're calling through SOAP unless you have some means of actually passing those headers on the request. So your tracing would stop there unless you are passing those headers and then having to some and then your SOAP request is where that's happening is also has tracing on it. Right. Yeah, does that make sense? So we don't have anything in Microprofile for doing that for JAX-RS calls as it stands, so you'd need to look after that yourself. And then obviously, in terms of tracing on the other side of the SOAP call, it would depend on what it is you're calling. So, if it's in .NET or something like that, then you'd need to have a look at, what's available from the OpenTracing side for that particular language. So, it would depend. But there are OpenTracing implementations for quite a different variety of languages. It's well supported in that respect. So I'll just do a short demo.
You can probably still show the matrix.
Sorry?
The matrix one, Prometheus.
No, the Zipkin.
Plus filling. Yeah.
Oh. So what I'll do here is, I flip back. I have a book service client here, so I'm just going to go and invoke this. So this is going to make a call into my book API. It's going to create a book, so we're going to make a request from the numbers service to get a number there. And then it's then going to add that to the database. In my book bean, I've got the code that was on the slide there, so we're going to just wrap this particular call here. That's going to take place inside its own span. And then we're going to take a look at what that looks like in Zipkin, so you can just get a feel for each of the spans and how that sits inside the trace. Okay. So let's run that. Okay, that looks like it's worked okay. So if I now flip over to Zipkin, I should say, give me the newest first over here, and find traces. So you can see I've got two traces that have come through here because there are actually two calls that have been made. One is that we actually do a post to say create the book, and then another one to actually to then actually retrieve the book information back. So if I take a look at this one here with the 4 spans, so this is our full trace. So you get a bit of a timeline here, so we can see how long each particular part of this trace took. So we can see in in our book API, this whole thing was our create method. We did a get here, so this is actually the call over to the number API. Because the trace ID and the span ID were propagated through to the number API, we get the span in the number API for the JAX-RS call there. So you might reasonably expect these to be reasonably close together, but you might see a little bit of overhead for your network. And then finally, right at the very bottom here, this is our span for the actual entity manager.persist call where we had the OpenTracing API where we were using that to create our span. And you can see here that we've got the tag that I created with the OpenTracing API. You can see that tag has been added onto our trace here as well. So that is pretty much it in terms of OpenTracing that I had to show you. Are there any questions just before I move on? Hopefully that makes sense and is relatively straightforward to use. Okay, awesome. I'll hand over to Jean-Louis to talk about job propagation. You set up with the cable.
Yep. All right, just before starting, we're going to be having a party tomorrow night that we are sponsoring. So if you guys want to grab an invite before the end of the session and you want to join tomorrow, just feel free to grab an invite and we'll have a beer or any other drink tomorrow night if you want to. All right, so we've got a few brave people staying in the room, so we're going to start with serious stuff like the security. Most of applications have security when they work in a monolith kind of architecture. When they go to a microservices, some of them don't really apply security on all the microservices. They usually only apply security at the boundaries, which is fine. It's better than nothing, but it leads to certain issues like the target issue earlier in the year in the US, where basically they were applying security at the boundaries of the company, and guess what? They just got a consultant in the company, and well, he was able to call all the services, and he collected a lot of credit card numbers in there, and did a lot of shopping. So definitely, we want to secure our microservices. Do you guys secure your microservices inside or just do security at the boundaries? No, just boundaries?
They don't secure it at all.
Yeah, no security at all? Well, that's the easiest thing to do. All right, so usually there are three main challenges in terms of security when you want to secure your microservices. So first you have to identify who is the caller. And make sure that is the person is pretending to be. You need to know what the guy can do with your microservice. Can he call the create method? Can he delete new profiles whatsoever? And when you are in the microservices world, you have the network in the middle. So you need to have some way to propagate your security context across all the calls. So you can track what the user is doing. So for that, we've got JWT propagation, which is also a spec from the Microprofile framework. It came quite early in the Microprofile world, just because it got inspired from other specifications like Auth2 and OpenAPI, which are token-based. Are you guys familiar with OpenID Connect or Auth2? Yeah. Are you using Auth2 with plain blind tokens or with JWT tokens? You don't know? JWT? Yeah. Yeah, that's definitely what you should do, because if you don't do that, then you just get a blind ID, a blind token, and you cannot do anything with it. And you basically just get a stateful architecture on the server side, so you don't get any benefits from the microservices architecture. So JWT propagation is relying on JWT, which is JSON-based. We have like a more complete example with all the JWT stuff available under this GitHub project. So if you want to grab the picture and try it later, you are more than welcome. We're going to be today just having a subset of the features that we're going to be looking at and trying. So in terms of JWT, we've got with the microprofile specifications everything to do role-based access control. We support keys on the JSON with the JSON format, and obviously all the configuration is available with microprofile config that Roberto showed us earlier on the presentation. So the goal of JWT propagation is first to extract and verify your token, make sure that the token is well formed, is available, and checks also the signature of the token. We'll get back to this a bit later. Then we're gonna just be reading the content of the JOT and extracting the identity of the caller. Remember that one of the challenges is to identify who is the caller. And then in order to enforce the authorizations, we're going to be extracting from the token all the roles and the permissions of the user, so we can then apply all the role-based access control to our system. So what is a JOT? Are you familiar with what is a JOT? Well, few people. I should have added more slides then. So it's called JOT. I don't know why. I don't know if you have the answer, but JWT is called JOT, and usually in the industry. What?
It's easier to pronounce.
Yeah, maybe. I don't know where it comes from. Anyway, it's basically a set of JSON maps, so quite easy format, and easy to use in different languages as well. Everything is base64 encoded, so basically what you get is a JSON map for the header, where you have the type of the token, the algorithm you use to sign the token, and some other stuff if you want to, the key ID, etc. And then you've got the payload, where you can add all the metadata you want, for example, all the roles, the username, and the issuer of the token, and many other things, the expiration date, when the token has been issued, etc. That gives you the body. Then you're going to base64 the header, you're going to base64 the body, and then you're going to assign it, and the last part is the signature, basically. The signature is very important, obviously, because you're going to be sending the token to the client, and instead of storing the state on the server side, like for the regular OAuth2 implementations, you're going to be sending the state to the client side. So you need to make sure that the client won't be changing the content of the token, so you won't be able to add any roles in there, for instance. So to do that, you're going to assign the token. So you send the signed token on the client side. It's pretty much like a signed cookie, if you wish. Same architecture. You're going to be building that, sending that to the user, and then the user is holding the state, so you don't have to, you can scale up more easily with that approach. There is also built in the expiration, so you know when the token is going to expire, so you can refresh it. So refreshing the token is basically requesting a new short-lived token, so that you can keep going and do other requests. So in terms of microprofile, we have like a first part which is to activate the JWT specification. It's not up by default. To do that, you have to basically add the logging config annotation on your JAX-RS application, and then the extension is going to be activated under the cover. Then you may want to extract some information from the token. They are called claims. So the claim is basically a key value pair that you have on the token. and therefore you may want to read the email claim from your token and just use it in your application. And then the last part is to basically do the role enforcement. So we'll see a bit later how it works. Okay. Do you have any questions? Okay, wonderful. The specification does not really tell you how to read the key, right? So, for instance, in this implementation, let me give you. The configuration is done using this CDI bin. And for instance, I'm reading the key from a PEM file, but basically I could be fetching the key from a remote server and therefore returning the key here. So basically the spec does not really gives you any requirements in terms of how you're going to read the key. It's up to you to read it wherever you want and just provide it.
Actually Microprofile config now adds properties to read it from class path, endpoints, any file.
Yeah, but that's more microprofile configuration.
Yeah, but it works together.
Yeah. All right, so I'll be starting up this thing. Oh, let me actually grab that terminal. Where's my window? Well, there. I'll make it a bit bigger. Is it big enough? So I'll be starting the two services over here. And then we're going to be looking at the number resource. Let's make this bigger. So in terms of number resource, I've been adding a role-based access control. So in order to call the number API, you have to have the number API role in the JOT. So previously, for the previous examples, we were using the non-secured endpoint. From now on, we're going to use the secured endpoint. And if now I try to call this endpoint, so this is the guest version of the endpoint, which is not secured. If I'm now hitting the secured one, I'm going to be having an exception, which is a 4.1, and I get the message that says basically I haven't sent any token in there. So in order to get a token, you need basically an external provider, which is going to basically check your identity, generate a token, and give the token to you. To do that, I'm using an API gateway that we have been working on in our company. But you can grab any other identity provider to do that. You may use Keycloak maybe, or Swisscale or any other identity provider for that. Again, I'm going to be using our API gateway because that's the one we've been working on, so it's easier. Let's see when it starts. There I go. So when the API is going to be up, it comes with some accounts that I've created in there so we can really test our token. So I've created on the fly some tokens like Alex, some accounts like Alex, which can create, delete, and update, and it has also the number API permission. We've got in there John, which can also call the number API and can create, but he cannot update or delete. And we've got Nick that can only delete, and Mark only update. And then I'm going to be grabbing some JWT tokens and make sure that I can call or not the number API. So to get a token with OAuth2 and JWT, we do what we call a ground type password, which is what you can see in Postman over here. And then you send the username and password, and you get back two things: the access token that you're going to use on a regular basis to call your service. And when the access token is expired, then you're going to use the refresh token to re-up your session and get a new access token, refresh token pair. There are different implementations in that regard, by the way. Some implementations allow you to reuse the same refresh token more than once, which, in my opinion, is not really secured, because it basically allows everyone that can steal your refresh token to basically force your session and create a lot of access tokens, and therefore it can hit you hard after that. So you should really pick an implementation that only allows the refresh token to be used once. So at least if someone steals your refresh token, it cannot fork the session into multiple access tokens. Anyway, so I've got the token over here. So it's a base64 encoded thing. If you go to jwt.io, there is a nice tool in there where you can see the three parts on the left side. So the first one is the header, the second one is the payload, and the last one is the signature. And on the right side, you've got the decoded version of the token, where you can see that the header has the algorithm used to sign the token. There is also the key ID over here, which has been used. The key ID is basically the key I've configured into the book's profile. So I've got the key which is let me put that a bit bigger. So I've got an RSA 256 with a key which is named my RSA key, and that's basically the key that I get on the token itself. And then you can see key value pairs. Again, they are called claims in JWT. You've got in there the token type, the not before, the issuer, then you've got the set of groups, and some email. GTI is the unique identifier of the token, and then the username and other stuff in there. And then the last part is the signature. So if you get the key, the PEM file over here, you can also validate that the token is correct. So if I take this token again, and then I go to the number API, and I had like bearer token over here, I should be able to call the number API, and the token gets validated, right? Now if I go over here and I take another account, or just I yank the number API from this account, right? Then I'm gonna grab a new token, and the new token obviously doesn't have the number API role. And then over here, I can change the token. And now I've got a 4.3, which is, you've got 4.1, which is basically you are not authorized. and now I've got a 403 which is forbidden. So I've got in, I've got authenticated, and then I don't have the permissions to call the service. Yeah.
That's all right. So you have create and update and delete
Yeah.
and number API all categorized into scopes.
Mm-hmm.
And so number API is the API where you have all the three permissions, or when you simply put create as a claim, what does it mean? Does it have a global permission on the application level, or how do you?
No, the create is basically the permission which is used on the book resource. So I've got in the book resource some operations like create, and the create permission is used there. So that's why I've got create and update and then delete over here.
Okay, so in real life example, you would be having multiple roles for multiple APIs, like the book API, reservation API, whatever, and then so
Yeah.
you have this, like a map, you have the create permission on the reservation API. So how do you?
Yeah, so the question is basically when you are using a lot of microservices and each microservice has its own set of roles, you end up by having like a token with basically all the roles of all the services that you're gonna call, right? Is that the question? So it's definitely an architecture choice again. There are many options. Obviously the easiest one is to put all the roles of all the services you are supposed to call, which works. We've been working for a company in Germany. They had like a very fine-grained set of roles, and we ended up by having a token which was too long for Nginx, because in Nginx you cannot put a header which is more than 248, I believe, something like that. So there is another spec for that, where you can basically exchange a token to another token. So basically you go to the service calls the API gateway and tells, I'm the service X, so please give me the token for me, and I'll give you this token in exchange. So there is a specification for that, where basically you can provide a small token that identifies the user, and you can request the API to give you the token for you, basically, with only the roles you are interested in.
Okay.
That's the way you would solve the problem, if you want to.
So basically, you have like a n number of operations. It's a create, update, delete, and then you have n number of APIs. In case at the end you would be having n times n nodes.
Yeah. Yeah, so it's really an architecture choice. Obviously, there are benefits of putting everything inside the JOT in the first place, because you carry on with all the roles, and every time you call another service, you just carry on with the context and all the roles. That's the way you would do as well if you were in a monolith application. You would just build the context of the user, and that's it. In a microservices world, if you want to go more fine-grained and only use what you are supposed to see in terms of roles, you can do the exchange protocol, and then you only get what you need. It's a good question, though.
Like that, they require claiming a lot. For example, okay, the user for this operation would have needed to claim wait, but
that's more the application server kind of logging. In this case, I don't know if we throw an exception, to be honest. I don't think so. Let me try this. Well, you have, so the annotation is the easy part. So when the annotation is used, you get a 403 period. So you only know that it's forbidden. You don't have enough permissions. There are other options to solve this. You can basically get the regular JAX-RS security context injected, and then instead of using the annotation, you can use a regular. Let me see if I have this available. Well, you can use the API to do that. So if you want to do, instead of create, you can do something like security context.is user enroll. And then it's up to you to catch this and do whatever you want to do. So if you want to fall back into another stuff, it's up to you. If you want to throw an exception, you can do so. So it's different option. And obviously, you can look for information on the token itself. So, for instance, in the token, I want to extract the username from the token. So I want to extract this claim from the token. And when the number service gets called, I want to just, throw out a log entry that says basically user X called me. So to do that, you basically use the claim annotation and the regular inject. And again, this can be the claim value, it can be a plain string, it can be an optional, so if the claim is not available, you get an empty claim, etc. So the specification is quite easy to use and gives you like a lot of ways to secure your microservices. And I think that's it regarding security. Is there any other question? No? Okay, I've got 22 minutes now. Let me switch to the presentation. Yep.
I have another question.
Sure.
Can the top also propagate it to the outgoing request? Or can it be propagated easily?
So the question is the token propagated to subsequent calls if you call other microservices, or is there a way to do so? The specification does not do that by itself, but it's also a very good question. You can get the microprofile JWT to give you the plain token over here. So you've got the plain big string, which is the token, and then you can add that as a header when you call another service. So the spec does not do that under the cover for you, but it gives you all the means to do that if you want to. Okay, so Microprofile OpenAPI. So when we work on our microservices, most of the time we have like our set of APIs, and obviously we want people to be calling us. We don't want to be writing microservices which are not used. And to do that, we have like many options. We can write Word documents or any other document aside from our microservices, and then we have to maintain both. And we know how it ends up. Most of the time the code is updated, but not the documentation. And then your users they can't really call you. So there is another approach which is basically combine the two, the documentation and the code itself. So at least doesn't prevent you from updating one and not the other, but at least it gives you the ability to have everything into the same place, and makes it easier to get the two in sync. The Microprofile OpenAPI is heavily inspired of OpenAPI specification or Swagger version 2, which is the same. Annotations should be similar, and this is a very, very important statement. You're going to find the same annotations name, but there is a trick in there. They are not in the same package. They are in a Microprofile package, which is not the default OpenAPI or Swagger package, which means that you won't be able to use the regular Swagger tooling with Microprofile. So the annotations are really the same in terms of name, etc., but they are in a different package, which is a bit annoying if you are used to Swagger tooling, for instance. So the way it works is that you're going to add some meta annotations. on your methods so that you can basically say what the operation is going to do, what is the expected response code, and you can also define the schema of the payload if you are referencing the class, for instance, that you're going to be returning back to the user. Because otherwise, with response, which is a generic response, you won't get any documentation. So by adding this, you can specify what is the object you're going to be returning. If you, same as for metrics and health and other specifications, when you deploy a Microprofile application to into a Microprofile server, you get out of the box the /OpenAPI path, which is available. And obviously, when you go and read the OpenAPI result, you get the YAML file. You can also get the JSON file if you want to. You know, in this example, I just used the YAML file, but you can read as well the JSON. In terms of example, there is not much to show in terms of documentation. So here is the full documentation for this generate method. The thing, if you go to book and you specify that you are using the book in terms of schema, then you can also document the book object with some documentation, and then it will show up in Swagger. So in terms of Swagger, basically you get this kind of YAML file as you know, as we have seen before. There is a nice Swagger UI you can use, and the good news is that it's compatible with the YAML file generated, which is good. So everything basically you're gonna be adding in terms of documentation in the code, you can just have it out of the box in the Swagger UI. So for instance, if I go to maybe 8080, oops. Oops, it's not running. Oh, it's not running. Anyway. So you've got all the documentations, and you can also try it out. So you can also invoke your service by adding, you know, the right arguments. So I believe that's the generate. I use the generate guest. You can invoke your service, and you get back either a result or something like it's not available. I don't know why, but anyway, the demo effect. But you can, with the UI, you can really get all the documentation. So instead of pointing your users to a Word document, you can just point them to the URL of the service, and they can read the documentation themselves. And again, it's the benefit of that is that it's always up to date with the code. So you don't have to maintain both a Word document, for instance, and this and the service itself. I can try the secure endpoint. Sure. Oh, I know why. It's using number API numbers, and it should have like yeah, it should have the context in there. So there is a configuration missing in the Swagger UI to specify that the service is running under the number API context. So that's why we get the 404. I should fix that in the project. Yeah, with the hypermedia links, for instance. Yeah, you can do that. It's not in the context of the OpenAPI. That's an implementation detail. So the hypermedia links is that basically when you create an entity, you return back the location of the created entity, so the user can discover your API on the fly. I believe that's what you were saying. But that's not part really of the OpenAPI. I think we do that on the book, if I recall it. Let me find the create method. Yep. So we can use the same approach. And so when you create a book, we basically are going to return the URI of the book that we just created as a header, so that you can then go and read the book you just created from the response you've got. But again, it's not OpenAPI. That's really something you can do in terms of implementation.
No, my question was, yeah, sure. This is exactly my question, but I was wondering, I mean, is it successful then, I get the new URL that I can
Oh.
API. So this information I would like to document it on the OpenAPI, but if it's in the scope.
Yeah. You can do that. In OpenAPI, yes, you can say when I have a 200, well, I've got an additional header which is location that gives you basically the link to the created entity. So you can definitely do that with the API response. You've got.
Think it's over there. Right? You could add the location header.
Yeah. So you can add like additional stuff in there. I don't know if I have it all. If I have a more complete example. Yeah, you can add a description, and you could add as well, some additional headers, I believe, in here. So you can add headers, and then say that you get back a location header with the link to the created entity. So you have that in the API response, with the hypermedia links as well. But I haven't really configured all that stuff in the example. So the link is basically the hypermedia links that you just spoke about. Okay. The last spec that we wanted to show you today is the REST client. The idea is the same as for OpenAPI. We are building services, and we want people to be calling us. The REST client is basically to enable microservices to call other microservices with a strongly typed API. So we don't want to be building like a JSON object and be signing that with Commons HTTP client, for instance. We want to be using like a strongly typed API, so at least we have compile time checks that can save us some serious bugs. Yeah, that's basically what I've just said. So it's a type-safe REST service over HTTP, as I said. It's extensible, and it's pluggable with OpenTracing that John just mentioned before. I'm going to show you how to basically propagate the OpenTracing stuff in there. And it gives you a more natural code style, so you basically are going to call the service with the interface as if it was a local service, but under the cover, the REST client is going to generate the remote call for you. So the way it works is that basically you're going to define the interface for the service, and you're going to flag the interface with registered REST clients. So when the extension is going to boot up, we're going to look for all the registered REST client annotations and then build up the proxy under the cover that does basically all the garbage for the network and the remote calls. And then on the client side, when you want to use this remote microservice, you're going to be using inject as usual, and then REST client. And you only specify the interface, and the REST client is going to generate the implementation for you under the cover. And it will deal with all the network and the serialization stuff. Sorry?
Where does the host come from?
You're gonna specify that in the. I don't know if that's in this one or in this one. We'll check that now. So for that, I'm gonna get back to 2 examples. So the first one is the simulator, which is using the book service interface. So it has like the register REST client annotation, and this is the interface. Below is basically how you're gonna be. Oh, let me remove this. Yeah. So below is basically the tracing activator. There is a bug in the current implementation we are using, so that's why we have like this workaround. But the idea is the same. Basically, you're gonna be specifying for the request and the response the headers you want to add, so you can propagate the OpenTracing context on the different subsequent calls. So this is the interface to use. On the interface, you can add providers, so that's the tracing activator we have below. And then if you want to use it, it's not the one. Book scenario invoker. So you're gonna be having this book service injected with the REST client, and again under the cover, everything will get generated for you. The target, I believe, is used somewhere in this stuff. I don't recall where it is. Do you remember where we set the target of the REST client? It's a microprofile config as well.
We have that on.
On there, or in this one.
Yeah, that's on the invoker.
Yeah. So on the book service, we're gonna be setting the URL that we're gonna be calling by using the base URL. That's the programmatic approach, as opposed to previously, which was the injected approach. And then we get the URL from Microprofile, as we've seen before. I've created 2 different ways to use the interface because one may use the OpenAPI to generate the interfaces with all the data objects which are used. So that's this approach, where, for instance, we have the book service with the create method that takes a book object, and the book object is also available in this module. That's the way you would do if you use the Swagger tooling to generate the interface and the data objects. And then when you want to use the REST client, you can use the strongly typed object. But in some cases, you just write the interface yourself, and you don't get really the objects generated. So you can also use a plain JSON object, and it's up to you to build the JSON object with a regular JSON API. So you have the 2 approaches. It really depends on your tooling. Either you use the OpenAPI and the Swagger tooling to generate the objects and the interfaces, and then you get a strongly type from end to end. Or you just define the interface yourself with the signatures, and then you have to build up your objects yourself, which is a different approach. I've given the information for the OpenTracing, and I think that's it.
Yep, I think so.
Yeah, that's it. And it leaves 4 minutes. All right, so we are nearly in the end. So there is one more thing that I wanted to talk about. There is a microprofile starter, which is beta currently. So it basically allows you to create a sample project. So you can pick up the microprofile version you want, then you click on the, I'll actually show you. So there is the microprofile starter. You can basically pick up the name of your group ID, the name of the artifact. Then you can choose which version of microprofile you want to try. For instance, the version 2. Oh, session expired. Awesome. Then you pick up 2.0, for instance. You can decide which implementation you're going to use, so OpenLiberty, Apache Tommy, Payara, or whatever. Let's say Payara. And then you can decide which specification you want to really generate the code for. And then hopefully it's not a valid name. And then if you click download, you get back an example that you can run locally. So hopefully I can open this with Atom. So it gives you an example that you can run with all the specifications in there. There is the profile for Payara Micro, so you can run all the example with Payara. If you want to use Liberty, you can then pick up Liberty and try Liberty if you want to. And the code also gives you some tests. And as you can see, you have like all this stuff as well available. I should open that actually on
Just for integration testing, just an example.
yeah. What's the name? That will be faster with IntelliJ. So you've got your application with the login config, the JWT over here. You've got the REST client with the fault tolerant stuff. You've got the health check over here. So you basically get a subset of all the specifications that you can try and run locally, so you can learn how Microprofile works. So it's very interesting. It's currently in a beta stage. So we are still improving it, especially adding new servers, new implementations, and new specifications. So if you try it and you find some issues, please give us some feedback so we can fix it. And well, future. So we are working on the Microprofile 3.0 currently, and we are also working on with the community on some additional specs that we're going to probably be including. So there is GraphQL, which basically allows you to, which is a query language to basically call all the microservices. There is a lot of work around the reactive programming as well. And well, we are discussing all those things together. If you have more ideas, if you are willing to get more stuff in Microprofile, it's an open community. So help yourself, go into the mailing list, say hello, and then let's discuss together of the things you would like to see in the specifications. And in terms of what we have been showing today, you've got microprofile.io, which is the reference website, Tommy, which is the server we used, and this is where you can find all the sources of the project. So if you want to take a picture, that's when you should take it. You can fork it. We build Docker images both for the Raspberry Pi, and we build Docker images to run on your own computer.
There is a Docker compose file, so you can boot up all the services. You can boot up Prometheus, Zipkin, and you should be able to test everything locally without the pies as well. And well, thank you. I hope that you enjoyed the session.